So good morning, everyone. Welcome. Thank you for joining Circular SMEs across Europe. This is the webinar today on circular water solutions. It is hosted by Zenit in North-Rhine-Westphalia. My name is Sabrina Rodrich. I'm here today with my colleague Katharina Fuchs, who is doing the technical operations, and with my colleague Tim Schürmann, who will guide you through the webinar with me today. We would like to thank the Polytech Trade Fair for co-hosting the webinar and for including us in their Polytech Live program, and also the Circular Week, who added us to their schedule. This webinar will be recorded. This is why we will only see the speakers and not the audience. We will now start with a video that will introduce the 4 SMEs who you will meet a little later today during the webinar. So please start the video. Hello from North-Rhine-Westphalia. Zenit is situated in the Ruhr area, a densely populated and traditionally industrial region. Here solutions had to be found for waste and wastewater from, among others, mining, steel and chemical industry. Intense research of academia and industry has led to environmental technology and circular economy innovation. There is structural change in the region. It brings forth IT startup companies who digitize environmental technology, facilitate its implementation, and who make the cities smarter. We are happy to share this know-how. We are member in the Enterprise Europe network, the world's largest network for innovation and internationalization of small and medium-sized enterprises. We promote the transfer of circular economy by identifying the right financing and funding sources for projects and by mediating international partners with the relevant expertise. We are happy to co-host this webinar with the colleagues from France, as we have a long-standing history of visiting the Polytech Fair with exhibitors and delegations from North-Rhine-Westphalia.
In France, water shortage is an increasing issue in specific regions, and this phenomenon will be stressed due to climate change. At Polytech Trade Fair, we identify more and more good solutions for a circular economy and the reuse of water. We are happy to co-host the CE event on circular water solutions together with NRW at Polytech Live, as it showcases more front-runner examples from all across Europe. Together we can hopefully come closer to solving this big challenge. In 2020, France has passed a very ambitious law to accelerate the implementation of circular economy within the next years. This law impacts cities, industrials, and citizens. For instance, by 2023, every city will need to have put in place solutions to allow the sorting of household bio-waste at the source in order to upcycle this waste and reduce the volume of general household waste. Lyon Metropole has already started experience to accelerate household bio-waste sorting and educate their citizens to do so.
For a long time, we have been managing water in a linear way, taking it in natural resources and using this water only for one usage before disposing it in natural water bodies, after treatment, of course. Now there is an opportunity to implement circular use of water, that is to say, many usage after taking only once the water in natural resources. And this is effectively possible thanks to systems like Nereus system, which are available at any size and can be implemented for hundreds or thousands of PE capacities.
At Synopsys, we develop on-site hybrid solutions to treat aqueous and solvent-based side streams from chemical and pharmaceutical production. These industries generate hazardous side streams that are not easy to process. Depending on the industry and the process, the side streams can contain toxic organics, active pharmaceutical ingredients, surfactants, metals, PFOS, endocrine disruptors.
We, as a part of the world, buy products like clothes, food, or cars that the industry produces. During this production, industries produces waste that goes to the atmosphere, rivers, seas, so on, generating a negative effect on the nature. What we do in AIS is to remove or transform this waste into useful things through biological technologies. This is a very efficient and ecological way to remove these hazardous substances from the environment. This way, we can clean the environment, assuring safe and healthy air and water for all. From our point of view, a society that wants to fight against climate change must go through the circular economy, in which nothing is wasted and everything is evaluated, mimicking the cycles of nature.
We were able to develop a new water, let's say, recycling kit, the Aqualoop recycling kit. And this kit consists of several components, such as the ultrafiltration membrane, such as a bioreactor, such as a controller unit, and so on. The basis for this was the Eco Innovation Project, a European project with 3 countries, Germany and Austria and Czech Republic. So this enabled us to offer different applications in water reuse. Simple rainwater harvesting, but also advanced rainwater harvesting, so we can drink the water, we can make coffee from the water. The next technology is the effluent of sewage water treatment plants, for example. So we can recycle this water, we disinfect and clean it, and we can use this water for flushing the toilets, for garden irrigation, and so on. The other field is stormwater management, so it's to get rid of the water. Detention systems to store the water for a certain time to avoid the flooding. Our idea is to close, let's say, this circular approach more and more. It's always a question of price and the investment and the regulations and so on. But it's possible right now already, which you can see here in the building. We have installed a lot of components and technologies to become more or less self-sufficient. Altogether, let's say, our building is an example for circular environmental working.
During this webinar, we will show how research results can be transferred to industry, and then we will feature good practices of SMEs from different European regions. They are closing the water circle in different applications. As water is a transsectoral topic, we hope to inspire many of you. Okay, so I'm really looking forward to hearing in a little while how these SMEs that we have just seen will contribute to solving the challenges of climate change, like we heard, water shortage, flooding, everything connected to climate change. But first of all, I would like to inform you how we will continue through the day. We will say just a few words about Zenit and the Enterprise Europe Network. My colleague Tim Schürmann will do that. And then we will hand over to Dr. Himanshu of Metabolon Institute and TH Cologne University. He will give us an insight into the latest circular economy research that have been done and transfer activities. After that, we will have the presentations from the 4 SMEs, whom you have just seen in the video. We would like to collect the questions or comments that you have until after these presentations. So we would invite you to put your questions in the chat or in the question and answer section that is there. And we will get back to them after all the presentations are through. As we mentioned before, this webinar will be recorded, so only the speakers will be seen and not the audience. So if you put a question or a comment in the question and answer section and it is directed to a specific speaker, we would like to ask you to mark that down as well. Okay, now I would say that we start with Tim Schürmann and the Enterprise Europe Network and Zenit.
Okay, good morning, everybody. Nice to be with you this morning. I'm about to start the presentation, so just give me a few seconds of multitasking here. Okay. Now can you see the presentation?
Yes, everything's fine.
Okay, wonderful. So I would like to introduce you shortly in the next 5 minutes to Zenit and to the project NRW.Europa within the frame of the Enterprise Europe Network, in which capacity we are hosting this webinar here today. So Zenit is the Center for Innovation and Technology. We're based in Mülheim, NRW, which is in the midst of the federal state of North-Rhine-Westphalia, which is in Western Germany. So it's the center of Europe. If you want to, we are a public-private partnership. So we're a limited company, but we do not have to work for revenues or shareholder value, but we work on mainly public programs and funding schemes that allow us just to recover our costs. Together with Sabrina and Kati, we are another 57 employees at our institution, and we have rough tech a turnover of around 5 million, which is more or less staff costs for the projects we work in. If you look in the business areas and expertise of our company, we have the topics innovation, technology, internationalization, and funding advice, especially for innovation, R&D, and international affairs. We do sponsor a network, as one of our shareholders is a network, so that's an important topic to us. We channel these our business areas in certain fields of expertise, and for us today, that is the field of circular economy or sustainability. Some years back, we had called that environmental technologies, but this is really the greening and the green topic we're working in with the company and also with the project NRW.Europa or Enterprise Europe Network, which is a one-stop shop mainly for SMEs in the fields of so the strategy of Zenit again, internationalization, innovation, sustainability, and also digitalization. And we look at the needs of companies and try to match them in European and international answer. And we do that not alone as a center of excellence in North-Rhine-Westphalia, but we do that as one node in the frame of the Enterprise Europe Network, which is the biggest network for access to markets, technology, innovation funded by the EC and many other companies around the globe. So there's more than 65 companies actually, and it's from Chile to China if you take the alphabet and the look on the globe. So we are operating quite international. What we do mainly is to inform about EU topics. We mediate cooperation partners in the fields of business, technology, and R&D partnerships. We look into technologies and cooperation opportunities by scouting fairs, operating incoming and outgoing delegations. We do sponsor the topic of technology transfer as broad and as wide we could, for instance, by exporting R&D results into SMEs. We do have a scheme where we support innovation strategies, innovation management procedures in companies, and we connect all those strategic assets and partnerships by the question of access to finance and funding for the above mentioned. So that's mainly what Sabrina and I are doing all year long. Sabrina is one of these global experts active in the sustainability topic and environmental topic. So the Enterprise Network is active in every European region, like the federal states and in Germany, or the regions in France as well. And those colleagues dedicated to a certain topic cooperate in so-called sector groups and thematic groups and bring together their needs, their expertise, their client requests, their client's offers. And this network effect is what makes Europe and the Enterprise Europe Network unique. It brings the European single market to life. And this is the USP we can offer. So we are activating local experts stemming from local and global in one word. Our focus on circular economy is holistic. So it's not just recycling or greenwashing, but it's really the challenge of especially our smaller companies along the entire value chain, from the first ideas on how to develop a product up to end of life and interaction with suppliers. And it's not just for suppliers, it's really for everybody to look at. And that's what we would like to do jointly with you during this webinar as well. So most important slides, if you want to contact us, and please do, as we have a broad portfolio and you can look into your needs. Here's the contact details for Sabrina and myself. And we're happy to, being here with you today. I'll just stop the screen. And I do have now the pleasure to introduce today's keynote. It's Dr. Himanshu from University of Applied Science in Cologne, so-called Technische Hochschule Köln. He is with the Faculty of Computer Science and Engineering, Automation, Energy, and Environment. You see him already on the screen, so there's a lot of water in his background. And his topic today for the next couple of minutes will be digitalization in water management, seen from a research and transfer activity perspective. And Dr. Himanshu, as you say, the floor, or in this case, the screen and the mic is yours, so please take over.
Can you see my screen?
Wonderful and perfect.
Okay. Thanks a lot, Tim, for the generous introduction. So as you mentioned, my topic for today's presentation is digitalization in water management. And I will give you a brief overview of our research institutes, a little bit about its very interesting history, and some of the projects that we have conducted now, which are related to the digitalization. So Metaboron, it's a very interesting research institute. If you see these images here, you can see all this garbage. And our research institute is located exactly at this site. However, this site is before the year 2000. So at this time point, Lepe in the city of in Lindlar was a landfill site. And this site was receiving waste from about 500,000 residents, and all sort of waste was coming in and being buried here. However, a very big change happened in the year 2004. New government regulations came in, and the landfilling of the waste was completely prohibited. Now the question was, what should we do with the landfill site? First option would be to close it. This option was fine, especially because the local residents for a very long time were complaining about the smell, the noise from the heavy machinery, and also, if you look carefully here, you can see all trees and hills. So it was an eyesore. If you go to the region, you see beautiful landscape, and then right middle of that, there's a garbage dump. However, there are a few questions. For example, like what will happen to the employees that are working at this landfill site? What will happen to the waste that's being generated by 500,000 residents? Where will it go? Because the waste generation cannot be stopped. Also, another thing was, what if something goes wrong with this landfill site itself? So it needs to have continuous monitoring for a very, very long time until we say, okay, that's a very settled system. So a bunch of very smart and visionary people came together, and this included scientists, administrators, people from local municipality, and also politicians. And it was decided that we should use this landfill site as an opportunity rather than as a problem, and convert it into a place of learning, a place for research, a place where industries can collaborate, and as well as transform it into something which is not an eyesore to the people, but where the local residents can proudly say, okay, we have this site, which is really wonderful. And the end result was, you can see this. And in my opinion, this sits very well with the local viewpoint. It's not anymore an eyesore. So what we have at Metabolon, start from this site. So Metabolon is a site where we are not landfilling the waste, but we still accept all the waste. The waste comes in here, it's source segregated. All the organic waste goes into either the biogas plant or the composting plant. From the biogas plant, we make electricity and sell it to the grid. Then if you see here, here are all the research buildings located from the Metabolon Institute of Technical, Cologne University of Applied Science. Then here is the biogas plant. Here are other big places to sort out the waste. And the USP of this site is we have direct access to the residual material, or you can say the waste. We have set up pilot scale plants that involve biogas plant. It involves landfill leachate water treatment plant. This also involves hydrothermal carbonization and pyrolysis. Also, we have industrial scale plants, as I mentioned, which are owned by BAV and Avia company. Then we have on-site expertise, both from researchers like myself, as well as from the people that have very long expertise in handling different kind of waste that are coming from BAV and Avia. Furthermore, we have set up industry relevant masters programs that are run by TH Cologne at the same facility, and the students get the first hands-on experience. They just not only sit in the classroom and talk about waste, they have opportunity to really see the waste and see what are the different solutions that we have developed and what can be done, how these waste can be managed in a sustainable fashion. The last thing is we have a site for interdisciplinary research, and name it, from engineering, chemistry, biology, also sociology. We do all of this thing at this Metabolon site. Next thing is digitalization in water management. So when someone talks about digitalization in water management, the water maturity model, this diagram, this explains the philosophy very well. So in short, to achieve an automatic control of a water management facilities, there are roughly 6 steps. The first 2 steps are setting up the basics, where you install the hardware, different kind of sensors to collect the data, and also you install some kind of network to collect all this data so that the data can be sent to a central repository. The next step is to observe the data, where we measure what's happening. We measure temperature, turbidity, pH, all sort of different parameters. The further step is to understand why it's happening. So if there's some change happening, what's the reason behind it? And based on the above 2 steps, we can build our prediction models, which will predict what will happen in the future. And the final step is when this model has been developed, it has run very well, it has observed a lot of data. We can give the complete responsibility to the model, where the model can take all the data in, it can predict itself what's going to happen, and also can take the steps, at least the preliminary steps, to solve it, whatever problem is being predicted that will happen. There's a very nice diagram about, if you look at the water delivery cycle in an urban context, it can be divided into various stages that can start from your catchment to treatment, distribution, water reuse, and water reuse, and as well as industrial water reuse, where our industry partners today will explain more. They will give very precise examples. If you notice in this image, there's a lot of queue mentioned everywhere, and each queue is the potential to collect the data. And one of the biggest problem is 97% of the data that's collected is remain unused. This could be due to several reasons, but the two big reasons are, first, there is not a long-term aim about how we will exploit the data, and the other one is the data is collected by a sensor, but it's not stored in a central repository. And this was the biggest problem when we conducted our European project called NRW, where we wanted to develop a strategy to standardize the wastewater treatment plant. The problem was the data was not collected at the central repository. So most of the time went into collecting this data instead of making any use of the data. Now I'll give you a brief overview of two of the projects that were related to the digitalization in the water sector. The first one is improved. In this project, our research group, along with the industry partner, developed hardware for the collection of the data that's related to the water quality. All this hardware was deployed at a water treatment facility in Thuringia, and our group developed a connectivity solution as well as prediction models for the event that can occur in the field. And the end result was a very nice web-based data representation where a user can see what's happening in real time, as well as if there is an event, then the model can predict if this event is just a fluke or an error in the data, for example, a sensor malfunction, or something a plant operator should physically go and look into. The next example is a project we recently conducted with the municipality of Bergisch Gladbach. And this was the development of prediction model for water leakage. So if you look here, the left image, if there's a large scale water leakage, it's very easy to at least locate and identify what's the problem. It might be very difficult to fix it, but you can, as soon as this large scale water leakage has happened, I think within a day or two, you will notice it. However, the big problem happens when there's water leakage at very small scale. For example, if you see in this image, so that's a real pipe and a little bit of leakage was happening from it all the time. So the aim of our research group was to develop a prediction model that can take multiple streams of data, which included the water flow rate, the geographical location, the age of the pipes, that was later identified as the biggest factor, and also many other factors. For example, within that region, what's the temperature cycle, for example, what's the environment factors happening. And the model that we developed, it took all these data as input, and this model can predict what's going to happen in the future with certain probability. And this is very helpful in, for example, saying, okay, within this region, now is the time you should do a physical check. And I can say with very high probability, when our model predicts that you should do a physical check within this region, there is some pipe that's either very close to being corroded or leaked, or leakage has already just begun. So we can very successfully predict where the next leakage is going to happen, and thus we can take preemptive steps to fix it. The next is we are conducting, at least for good 20 years, our research group is doing different kind of projects that are related to water, especially the digitalization of water. And recently we have entered into a collaboration with the Competence Centrum KWD, which is Competence Centrum Digitalis Wasserwirtschaft. So this center is originally located in Essen. However, since we have entered into a collaboration, they are going to set up a new center in the Gummersbach, which is very close to the Metabolon research facility itself. And we're going to focus into these 4 core areas, which are monitoring. So all different kind of sensors, the maintenance of sensors and everything related with the monitoring of water and the water quality. Knowledge management, so documentation and communication of all the data that we have collected or all the reports that are being generated. Furthermore, we'll focus on networking and networking with environmental and customer data. And the aim is to provide all the data available on the web. Also, we'll look for the cybersecurity and cloud storage solution, but also how we can save the data, how we can preserve the data from hacking or unauthorized access. So here's a little bit of advertisement. So we are always looking for industrial partners, and the Competence Center KWD will also now be our partner into this. And we are doing many projects, not just on the national level, but also on the EU level. So anybody who's interested in any of the industrial partners, you can come and join us. And if any of the master thesis or PhD students are listening, you're also always welcome to come and contribute to our research group, because we always have different kind of research questions that are left open where you can contribute and you can also learn a lot. With this, I end my presentation, and I guess I will take the questions at the end of the presentation. Thank you very much.
Yeah, thank you very much, Himanshu, for giving a good overview about what you are doing in the area of circular economy research and what Metabolon has in terms of opportunities, and also how you are cooperating with industry. So we would suggest that we move on, and that any questions and so on, please put them in the chat and in the question and answer section, and we come to them later. We will move on with the circular SMEs that have been introduced in the video before. And the first one we have is from North-Rhine-Westphalia, the first presentation. We are very happy to introduce Oliver Ringelstein, the Managing Director of Inteva from Aachen. We have known the company for many years, and we have witnessed and partially accompanied them innovating, growing, and even making the office building circular. And the circular building will also be the topic of Oliver Ringelstein's presentation. So please, the floor is yours.
So thank you very much for the introduction, Sabrina. 1 second. So you all can see the presentation, yeah?
No, not right now.
Not right now. Okay, excuse me.
Okay, now we can see your
desktop. So
yeah.
Excuse me. So okay, so here it is. Yeah, thanks again for the time and the possibility to do this little presentation here. Yeah, and the topic we're talking about today is our own company building. So here a brief overview about what I would like to explain to you today. So it's first a few words about our company, then our company building, and then it walks through the, we call it a 360-degree online exhibition in the building. So you all can walk through by yourself. Yeah? Very helpful in Corona times. And then last but not least, some findings. So what are we doing in Teva? Is focused on water reuse on the one hand. So we recycle rainwater, recycled grey water, effluent of sewage water treatment plants. And so all what we can get, all the water sources we can get, we try to recycle and use this water again. And then for different applications, so from simple process water, irrigation water, but also flushing the toilets, up to potable water quality, and just for fun, also beer production. So it's just to demonstrate that the water can be used for more than just for toilet flushing if you recycle the water. The second business field of Inteva is stormwater management. I very often say, so it is how to get rid of the water. So in a lot of countries, we always have the problem of flooding, as you know all. The last month we had severe flooding problems here in North-Rhine-Westphalia and other areas as well, so Belgium and so on. So it's with the climate change, it's a severe problem. So so this is the second major business field we are in. So here you can see our our company building. So a few years ago, 2018-19, we decided to move into our own building. There was a chance here in Aachen. Of course, space is limited and everything is expensive. So you think more than twice before you build your own company building. So just to give you a brief overview, we are located in Aachen in Germany, which is very close to the Belgium and Dutch border. So I myself live in Belgium. It's only 5 minutes from Aachen. We have 3,000 square meters around of property and 700 square meters office and developments, 500 square meter warehouse, 20 co-workers. So it's a small company. And when we started to build this this building, we said, okay, so we sell products for rainwater harvesting, greywater reuse, water reuse, stormwater management. So of course, we have to integrate everything that is possible in our own building, but not only for research and development, but also to demonstrate that this is today possible and it is affordable, of course. And then the second thing we stepped in was energy consumption, and we said, okay, with the new building, we also want to show and demonstrate that saving energy and is possible as well. So we have around 20,000 kilowatt hours energy consumption. We have 250 cubic meter water consumption in a year, which is not a lot with the 20 co-workers. But we have 2,400 cubic meter of rainwater yield in a year with the 3,000 square meters. And so of course, you can see that there's much more water we might harvest than we need. So this means that we have to get rid of a lot of water. So now I stay here with the slides because of the time. So brief overview about what is installed in our building is, on the one hand, we have we catch all the rainwater from the roof, and we recycle this water and we use it for potable water. So this is quite special, and probably we are one of the only, maybe the only company in Germany doing this. Why? Because simply we have it's not allowed in most of the situations. So we need to connect to the water supplier. So this is one of the main problems we are facing when we want to be independent in water supply. So the second technology we are working with and testing here in the building is the process water from the small sewage water treatment plant, and it's the same. So we are connected with the building normally to the water supplier, so we don't need a small sewage water plant. For us in the special situation, it is allowed. Why does it make sense? Of course, it's easy. We can collect all the water and we can recycle the water. And here in this case, we use the water again for toilet flushing, for example. We have a green roof, and we catch the water from the green roof. Of course, most of the water is evaporated. So maybe, let's say 30%, 40, 50% are, let's say, catch in the rainwater cistern, and this water is reused again. So here we have some problems with color. So we remove the color with oxygen and different processes to get clear water to use it again for different applications. Here in our case, only irrigation. We have stormwater infiltration, of course. So this means the water from the surface is collected and infiltrated, stored to avoid flooding. We have a PV system, which is something around 20 kilowatt. This means this is sufficient for our whole building for the energy supply. It's a small system, but with some other technologies, let's say, it is possible. For example, the heat exchanger, which is very important to my mind. So we can save around 50 to 70% just by using the heat from the building. Again, heating up the cold air from outside. We have home automatization system installed. This means you don't need to press any switch before you light. Everything is automatic. So we have the heat pump, of course. So with the heat pump, as you all know, you can save a lot of energy. We have floor heating, which is basic, let's say, basis for have a good efficiency for the heat pump. But also for cooling. So in the summer period, if it is outside, let's say 40 degrees, in the building is always 22, which costs nearly nothing because we simply heat up our source outside. We have 2 deep bore wells, and then we can use the heat in for the heat pump again. You can see the deep drilling, and we have, of course, unsealed traffic areas. So this means all the water we do not need is infiltrated on this area. Yeah, now I would like to take you with us into the little tour through the building. So you can do this by yourself. Here is the web page. So the web page from the building. So it is building.inteba.net. If you go to the web page, you can learn about the building. You can also see some pictures of the construction phases and so on. It's quite interesting. So, and here with this 360-degree exhibition, so these are pictures, and you can walk around. Here you can see the drain max infiltration tunnel. Normally, of course, this is buried. Yeah. And this is an elder picture. So today we have the sealed surface here, the unsealed surface. Underneath here, you can see you can find the GRP tank, a 30 cubic meter tank to collect the rainwater. And yeah, this is the office building. And over here, you can see the stock, the warehouse. So when you go into the building, then you will be directly into our plant room. So this is suitable for research and development. We have different pipe works grids installed in the building, so we can connect different pipes to different applications. And on the right side directly, you will see our potable water from rainwater system. Here we are working with ultrafiltration membranes. You can have a quick look into the tanks. On the left side, you can see the membranes. On the right side, you have the clean water. And then the water is pumped by these rainmaster units, frequency controlled through active carbon and UV disinfection into the building. So this means if you have a coffee, tea, or whatever, so in our buildings, then it is made of rainwater directly. And then in the middle, we have the plant for the reuse and the cleaning of the effluent of the roof. Here we're working with a new plasma technology to clean the water, to get rid of the color and so on. And on the left side, we have the the process water, so-called process water from the sewage water treatment plant, which is, for example, quite easy to recycle and very suitable for toilet flushing and so on, washing machine, maybe garden irrigation. So, and then the last step here, because probably the time is running. You can see our grey water recycling system, which is not installed, but soon we will install the so-called multi-loop system, which is a grey water recycling system. You can shower again and again with the same water. And here, this is only an example for larger systems, just to show you that these are our systems we are producing and selling. This is, for example, a system for 100 persons, for 100 people, grey water recycling system. So, and then finally, oops, the last slide. So, yeah, during the last years, some findings. Being water self-sufficient and energy neutral is possible for a lot of buildings today already, and it's much easier than expected, and it's not as expensive as most of the people are thinking. So it's mandatory to our mind to do it. So systems, they have a low maintenance effort, they're easy to handle. We are reaching highest water standard, and with rainwater, we are reaching much better water standards than a lot of potable water you can get in different countries. As I mentioned before, technologies are affordable and often have very good return on investment, especially if we talk about grey water recycling, because they have a small footprint. The main barriers we're having are the local regulations and existing structures. Yeah, so this is what we have to do something against. But more and more utilities and countries are supporting decentralized water reuse solutions today. So this means we are on a good direction. And yeah, as I mentioned before, to all mind, for any new building, it's absolutely mandatory anyhow, but also a lot of retrofit possibilities. We are seeing this in the building market. And yeah, our future goal is to fully close the water loop. These are the projects we are working on. And yeah, everybody is invited to visit us and to work together with us. Thank you very much.
Yeah, thank you, Oliver. I think that's very interesting to see how the water loop is being closed and what the future of the buildings will hopefully look like. We have to move on quickly to Catalonia now, where we are very happy that we will have the technical director of ARIS with us, Albert Bartoli. And we have seen in the video already that you're dealing with waste as well as wastewater. And so now we are curious to learn how you are turning wastewater treatment plants into biofactories. So please, the floor is yours.
Thank you. I'm going to share the screen. I hope you are all watching my screen. First of all, I would like to thank the organization Zenit for giving us the chance to explain our solutions. Our solutions are mainly biological solutions, and the biological solutions that I'm going to explain are a clear example of circularity. ARIS was established in 2009. We are a spin-off of the Universitat Autònoma de Barcelona. There are many environmental engineer companies, but there are few able to deal with water, gas, and solid problems. The knowledge of these three vectors give us a wider solution that allows us to find more integral solutions. By our origin, we are highly compromised on the research. These are some of the ongoing EU projects that we are involved. And here you can see some pictures of the equipment that we are applying in some of these EU research projects. Talking about the topic that we have to explain is like turning wastewater treatment plants into biofactories. As you will see, some of our solutions are very a clear example of this. The first of all, it's the odor problem in wastewater treatment plants. With our technology, it's a biological solution compared to the chemical traditional technology. We don't use chemical reagents to solve the problem of odor. The only thing that we need is the effluent from the wastewater treatment plant. So like this, only with the effluent from the wastewater treatment plant, we can solve the odor in this plant. So like this is a clear example of circularity to solve problems in these facilities. Also, another example that I would like to explain is the solution that we can apply is the biogas desulfuration. Also with a biological solution, we apply a partial oxidation of the H2S to produce elemental sulfur, and this elemental sulfur can be applied as an agriculture nutrient. Okay, so like this biological solution, it's a very interesting way to face this problem of the biogas desulfuration. The third solution that we're going to explain is the BOC elimination. Traditionally, this pollution in the air, it's treated through a regenerative thermal oxidizer, it's RTO. This technology consumes fossil fuels and it's generating all time CO2. With the biological approach that we supply, we have a minimal impact on the environment. Another example, changing a little bit the topic, it's about solids management. It's a very interesting solution that we could find. It's like in a wastewater treatment plant in Pineda. It's a city 60 kilometers in the north of Barcelona. This facility had two anaerobic digesters, but they were oversized. So together with the local administration and the company responsible of the exploitation, we first studied and then applied the possibility of sending dehydrated sludge from smaller wastewater treatment plants near this wastewater treatment plant of Pineda. These smaller places, like, well, it's arranged in this smaller wastewater treatment plant, they didn't have anaerobic digestion. So like sending this sludge from this small wastewater treatment plant to a much bigger centralized wastewater treatment plant, this Pineda, we could transform this waste into biogas, and also like we could reduce the volume of sludge generated. The payback of this investment was smaller than 2 years. Here you can see a little map of the location of the plants that were related to this project. Like here it's Pineda, and in spot, I don't know if it's can see clearly, but like the other smaller wastewater treatment plants that sends some of their sludge to Pineda. And the last experience that I would like to explain was like that in a paper industry, we could transform the glues and the inks wasted into biogas through an anaerobic membrane technology. And also like this solution was a very short payback. So like I don't know if I have been on time, but like from to here, it's our in a very fast way we would explain our solutions and our circular approach to them. so yeah. For me, I've finished. I don't know in short time, but like, thanks
Thank
for.
you very much. I think that gave a good overview about your applications. Very interesting. And as we said, any questions can either be done in the chat, or you can also get in touch later via the B2Match platform with Albert Batroli, or let us know if you need to know more. So then we will move on to France. We're very happy that we have Emmanuel Trouvé, chef d'entreprise of Nereus, with us today. And we have seen in the video that there are a lot of applications that you are dealing with, but today we will see something about food and beverage, wastewater treatment solutions and fertilizer production. So we're really curious to hear about it.
Thank you very much. Nereus is located close to Montpellier in the south of France. And our DNA is to design and construct and operate sustainable systems, helping especially industry, but also buildings to install a circular management of water and other items that are in wastewater. What we do is mainly using as a heart of our process dynamic filtration. And dynamic filtration is completely different from tangential or cross-flow filtration in a way that we move the membrane using rotative disc membrane instead of moving huge quantities of liquid along the membrane like it is in cross-flow filtration. This way, we save a lot of energy for the same result. I would like to compare the two approaches. The classical treatment approach we have is usually to get water for an industrial use. And this is a real case we have of 30 cubic per day water consumption for this industry. And the normal loop is to treat this wastewater and to dispose the wastewater into receiving natural water bodies after appropriate treatment, of course. The difficulty is that it's a linear use of water every, or let's say a large cycle, water cycle, and it is a case we have now. What we propose now is to have a local or an on-site loop, recycling almost 80% of the wastewater, and this, as a result, decreased drastically the water uptake in natural resources. And you can also go to zero liquid discharge. Of course, you have to manage the concentrate or co-product you get out of this water recycling loop and to value it. So the system we have to do these are highly modular and flexible systems, like an example here with this mobile unit that can help to go to demonstration or to do services. You have the disc in these white tubes. You have underneath a heat exchanger. So at the same time, we recover water, and we also recover heat out of the wastewater. Something that is key in doing this is to account for to secure the health, the sanitary aspect of the water. I don't want to go yet through this scheme, but just to show you that we can study case by case how to secure the sanitary aspect of the recycled water. Here you have an example of a distillery in Martinique, Caribbean area, where they were used to treat their wastewater into lagoons, like you see on the top left. And we substitute their big lagoons. You see the capacity is 1,000 cubic per day by only 4 containers. It's a very compact installation. You see the installation inside. And this way, we are able to convert their liquid wastewater called vinasse into clean water. More than 80% of this volume is converted into high quality clean water that can be recycled upstream to wet the inlet sugar canes in the rum process. And the two concentrate from the ceramic disc, rotating disc stage, and from the polishing hour stage are directed to a neighbor composting unit for fertilizer production, fertilizing sugarcane fields. So there is no more need for big wastewater treatment plant for big lagoons. So they also save a lot of space and room to develop their activity. So we can say that there is a lot of value for industry moving from wastewater treatment to wastewater sorting, I would say wastewater cracking into clean water, into other ingredients, and especially for climate change adaptation, they can get much less vulnerability in case of tension on water by authorities reducing water access. So I would say that all the stakeholders have something to gain in such an approach. It is listed here what is the value for public water utilities, for territorial authorities, for water authorities. So it's clear that circularizing the water management has value for all stakeholders. I will be happy to give you much more details and much more information. This is also applied in many food and bev industries, like dairy industries. And we will also be happy to make visit of those sites with you. Thank you.
Yeah, thank you very much. Very interesting to see what is possible and what you are willing to share with the audience. So I think you said how to contact you, otherwise it can be done via us. So please let us know. So we already come to the final presentation of the SMEs. And as we just heard from Oliver Ringelstein, it's not very far to Belgium. Flanders is just around the corner for us. We have a lot of chemical industry here in North-Rhine-Westphalia, as you will know, Stephen. So we're very curious to hear about what you can do about chemical side streams. And so we look forward to your presentation. Thank you.
Thank you. I will try to share the screen. So you should see the screen now. I hope so. Can you see the presentation?
Yes, it works fine.
Top. So very short, in a few minutes, not enough time to explain everything, and I will do my best to give you a little bit of a flavor of what we can do. I'm Steve De Laat, founder and CEO of Inopsys. So what we do is we focus on some of the industry challenges. We already saw some challenges. Those are in the area of wastewater treatment, and also the challenges you have with wastewater treatment and also recuperation of water. But some of the topics or some of the streams that we often forget are the hazardous waste or hazardous wastewater streams that unfortunately end up in transport and incineration. So then I'm talking about streams that contain toxic organics in general, coming out of pharmaceutical industry, active pharmaceutical ingredients, more specific steroidal hormonal components, often also forgotten are types of surfactants. Okay, some of them are already on the ban list, but still used also. Then solvent water mixtures, too much solvent to go into the biological treatments, too much water to go for recuperation, distillation. So they also end up in transport and incineration. Then the whole topic of heavy metals, most of the cases, these are also catalysts, palladium, zinc, vanadium. And then a very hot topic is all the chemical compounds that are considered and will be considered more and more also as endocrine disrupting components. So influencing our hormonal balance and also linked to certain diseases. And then in Flanders, Belgium, we have now a hot topic about PFAS, but this is definitely a topic that will be very important also in the rest of the world. So what we see is that those streams that are considered non-treatable end up in transport and incineration as the best available technology. Disadvantages of this are, of course, transport and incineration create also a kind of CO2 footprint that could be reduced. The costs are increasing. It's a linear approach. You destruct the water and the components and the raw materials in the water present. And we also see now more and more that it's dangerous because you mix up streams, and this can lead to certain very dangerous situations and also explosions. So we at Inopsys, we believe in circles, and we try to provide the missing link that sometimes is missed. When we saw the previous presentations, a lot of waters can be recuperated, but these harmful, hazardous waste streams are very difficult to recuperate, and even with the technologies mentioned. So what we do is we create a missing link that the water loop can be closed, and that also certain raw materials, catalyst, solvent can be recuperated, and that the pathway towards transport and incineration is totally closed for our customers. We have some customer cases, very short, to highlight that we already implemented. One in pharmaceutical industry, one in fine chemical industry / pharmaceutical industry. So here you see two examples where we implemented an alternative for transport and incineration for a side stream coming out of pharma and chemical industry. In one case, we recuperate zinc, a catalyst used. In another case, we recuperate palladium, a catalyst used. We create on-site purified water, and the raw material is recuperated and a value is created for the customer. So costs are decreased, CO2 is decreased, and value is increased. This looks like this. For example, these are mobile modular units that we put on site, remote controlled, self-steered, and so on. So these units can be very compact and can then avoid the transport and incineration of those hazardous side streams and can generate the recuperation. Another case where we focus now more on the organical part. So this is an API that is produced to treat prostate cancer, for example. So it's a steroidal component, has to be removed less than 0.01 ppb, parts per billion. We do this in a technology train of two technologies. Part of the technology is an extraction process where we recuperate also the solvent that is used. We can also take out the catalyst that is used, and of course the steroidal component is taken out of the water. So you see multiple circles and loops that are generated, and the linear transport and incineration line is closed. So the customer stepped away from this approach, has a cost reduction and a more sustainable process on site, and can go also for water reuse. And this looks like this. So it's a plug and play. We use the existing infrastructure where the trucks are loaded to go for transport and incineration. We put in our units, ATEX, zone 1, zone 2, everything is possible in production in loading areas. And in this way, the transport is eliminated and the reuse is done on site. Another very hot topic is the pie, or all the micropollutants, but more specific, the pie, the pharmaceuticals in the environment. And to be correct, we have to mention that 90% of the pie is generated and caused by the patients and not by the industry. But the industry is aware of their part of the problem. So in this case, we developed for a pharma company a total solution to remove more than 23 different APIs altogether out of their wastewater to make them pie-free. I think this is quite unique. And you see here then an example of a bigger unit. It's still modular and mobile, but we have chosen to put it in a closed environment. And here we use, for example, also advanced oxidation techniques combined with other techniques, because it's a very complex wastewater, to make this site total PI free. So what we do in a nutshell to close the presentation, we provide also mobile and modular solutions on site, capex free. So we do the investment, the customer pays per use. We create in most of the cases a circular economy approach, in that sense that raw materials, one more, and water can be reused. Very important compared to other mono technologies is the selective removal. You don't have to remove everything. You have to remove the problem-causing component. As we already saw in the previous presentations, if you do this, there are other techniques and wastewater treatment in general that can be used to create purified water and to recuperate it. And at the end, what we do is we design, build, finance, operate, maintain. So we take care and we unburden our customers in this quite challenging topic. Of course, we help them in achieving the Sustainable Development Goals. And then I want to thank you for your attention. And if there are questions, I'm happy to answer them now or later on. Thank you.
Yeah, many thanks for presenting your technology, your business cases, your ideas on how to make water circular. Very, very impressive. I've taken away that there is it's high tech. It's close to science. We heard from Albert. He's our spin-up from university. We have seen the sketches and the process flows in the other presentations from Imran and Stephen as well. I do know from Matteo and Oliver that he's also engaged in regional and international R&D expenditures to promote and to test and to transfer the technology. So it's really interesting to see how a technical window of opportunity opens along our energy prices and the rising awareness. We've seen the icons of the social, they are United Nations Sustainable Development Goals are 6 and 12 for water, sanitation, and here on Stephen's second to last slide. So it's really interesting to see. We do have one open question from the chat, which I would like to put first, and then we are about 5 minutes behind schedule, so we can have a short discussion or ask for further questions from the audience. So that would be the first thing. Please do either use the chat or the F&A art instrument tool to ask your questions. And we have one question from the audience to Nereus, to Emmanuel, and the question is on the specific energy consumption for your dynamic ceramic filtration, and the answer should be in cubic meters, if you like. I hope the question's clear for you.
Yes. Maybe you've seen on images that all motors are on speed controllers. So we use just the appropriate rotation of the disk to manage the fouling and to control the production of the system. So it could be that we have to work at 25 Hertz or up to 60 Hertz, for example. And it means that we adapt the energy used to the need. In the case of the rum industry I presented, we have the chance to work at high temperature. The working temperature is in between 70 and 80 Celsius. That allows very low viscosity and very low energy consumption. So the energy consumption is in between 0.8 and 1.4 kilowatt per cubic meter in that case for the ceramic disc operation. And of course, it It could be higher if the working temperature is lower. It could be higher if the viscosity is much higher with a very high loaded stream, and it could be also even lower if we use the technology on easier effluent. So we adapt the energy consumption to the actual need.
Many thanks for that elaboration. Very precise question to very precise answer, so thanks for that. I'll just ask in the chat if there is anybody who wants to pose a question. In the meantime, I would like to hear an answer from maybe not all of you, but everybody of you could answer up to the question. What are the obstacles you're facing as eco-innovative entrepreneurs and doing things different in a very traditional market on water and energy with a lot of regulations you got to deal. So maybe we can have an answer from an entrepreneur side and maybe one from Himanshu from the science side. And anybody to volunteer from the business cases? Otherwise, I would put the question on the science side first. Oliver, would you like to answer to that? Or shall we ask Metabolon first?
I think Emmanuel has the hand raised.
Okay, sorry. Messi, you want to?
Yes, I would like to highlight that one of the key obstacles is regulation. It has been mentioned in other presentations before. And the regulation is clearly not sufficiently ready for circular economy. The status of all the co-products you can obtain doing appropriate effluent tracking. We've seen several solutions that help to separate the different ingredients of the wastewater and eventually to separate them at source. And then we need to have appropriate regulation and appropriate status of all these products to put them back into valuable circuits, into production circuits, into usage circuits. So this is the key obstacle we face at the moment to develop circularity of water and other ingredients.
Yeah, many thanks. I would pass that on to Himanshu and would like you to see it from the science side, and regulations are probably also part of the research you conduct as well, and in the frameworks you operate in.
Yes, Tim. As I mentioned in the presentation, one of the very big thing is we look for the project on very large scale, and the big problem is a lot of data is being generated, but it's not coming to a central repository. For example, if you look at a wastewater treatment plant, there's so many sensors installed: temperature, pressure, pH, conductivity. The data is recorded, so you can either see an LCD screen what's the value at present time, but either it's not stored for longer duration, or the sensor itself is not capable of sending the data into central repository. And that's the biggest problem that comes to us. If we do not have the data, we cannot improve the system. And this part is also connected with a lot of legislation, because there's a big debate about data security and privacy. So a lot of time when we go to wastewater treatment plants or water treatment plants, there's always a very big contentious issue how we'll solve the data privacy, because they're always very afraid, oh, we cannot give you the data. And the data has to make those kind of agreements so that we can share the data. It takes a lot of time. For example, sometimes companies put in clause like, okay, only we need the name of researchers who will exactly work on the data and nobody else. But as I mentioned, sometimes we have very good bachelor thesis, master thesis students, and they cannot work on these projects because we cannot give them the data. So both from regulation sides, yeah, they need to loosen up a bit, or they need to be revisited, because I think that the regulations are pretty old. And as Emmanuel mentioned, to make them into circular economy, we need to update them, and also all the sensors that are connected, we need to find ways to collect this data into a central repository. Thank you.
Yeah, many thanks. We have no questions from the floor, so this would for a short co-comment from your side, the chance to clarify or to stress or to focus on a certain aspect if you want to. If not, we are just 3 minutes behind schedule, and I would pass on to Sabrina. So if I see anybody unmuting and starting to talk, I don't, so I would pass to Sabrina and say many thanks for your for the glimpses into your technology and seeing how dense and how forward thinking it is, and best of luck with your business endeavors. Best of luck with spreading your technologies, and I hope today's seminar is one of the steps you take in order to promote your business and your technologies. Many thanks on that, and Sabrina, please take over.
Yes, so thank you everyone also from my side. We have one more speaker, so I'm very pleased. As I said in the beginning, this webinar has also been added to the schedule of the Circular Week. And we have Agnieszka Scink of Innovo here today, and she will tell us a bit about this Circular Week, which is starting today, and there are lots more webinars and events that you might want to catch. So please, Agnieszka, the floor is yours.
Good morning, and thank you for invitation, and thank you for joining our initiative, which is Circular Week. And I will maybe show you like very short presentation. Wait a second, yes. So Circular Week, it's about engagement, involvement, and taking all enthusiasts of circular economy together, where we try to talk about the transition and how we can achieve our, circular future. So we try to, for a whole week, talk and show different aspects of circularity. And it is organized for the 4th time. We also a member of Circular Economy Stakeholder Platform, powered by European Commission and Social Economic Committee. So we also organize it with cooperation of this initiative. And as I said, for the whole week, we would like to show different aspects, different sectors where circular solution could be implemented. So it started today, and a lot of different webinars, seminars, meetings will taking place during the week. You can check the website. There is the address of the website is just circularweek.org, and then you can see plenty of different events, and you can check what is the most interesting for you and register and be with us during this time. One event connected to the water solution and about different ingredients which we can retrieve from the water will be, for example, on Wednesday, organized with Canadian partners, and then we can find out about different Canadian technology, what could be implemented in wastewater treatment. So this is one of the highlights connected to topic of today event. And the last day on Friday, there will be big international congress, Mazovia Circular Congress, October 15. It will be all online, so you can go register and watch it online wherever you are. So it is, as I said, organized for the 4th time, and our community is growing. It's around 50 events. It's already organized under this umbrella, and as Sabrina said, today's event is as well on the list. So please just join us, and I will be happy to join forces and spread the messages about the circularity and about circular future. So I think that's from my side, as I thought to have 3 minutes. I hope that I managed to do so.
Thank you very much. I think we got the idea, and I think it's a very exciting initiative, and I wish you good luck, and that the community will grow, because it's such an important topic. And for everyone, we have put the link also in the agenda of today's event. When you go to the B2Match website and go to the agenda, you find the link. We will also make available those presentations if the presenters agree with publishing them. They can send them to us and we can make them available there. We will make available the introductory video and probably also the whole webinar, so everybody can check again if they missed something. And so speaking of the website, I mean, today we met 4 SMEs and we met a researcher, but on the B2Match website, you find a lot more participants who are have registered with ideas, with projects, with questions regarding the circular economy, and more than 200 of them are available for bilateral meetings. So it makes sense to check out the website, look at the list of participants, look at the marketplace, and see whether there are interesting connections that you can make there. Furthermore, we have more webinars coming up. There will be one next week. Check it out on the website on batteries and vehicles, if that is of interest to anyone. And then next year we will continue with manufacturing, with food and others. The website and the marketplace will be online until next year. We continue through until the circular hotspot in, yeah, thank you. The circular hotspot in North-Rhine-Westphalia in Bottrop. That will be next year, and that will kind of close the loop of these events that we are planning. So thank you very much from my side for joining us today. And we hope it was inspiring for many of you, and that contacts will be made even afterwards. Thank you. And sorry, I would also like to thank, of course, all the organizers here, the Enterprise Europe Network partners who are involved, our travel partners involved, especially the Kompetenznetzwerk Umweltwirtschaft NRW, who are really accompanying all of these webinars. So thank you very much.